Suppose you're a venture capitalist. You have some money to invest and you're looking for a good return on that investment. And imagine that a research team from Harvard University comes to you with the following business proposition. They say, we have what we think is a cure for male baldness. If we're right, then of course we're going to make a ton of money off of this because men all over the world will be willing to shell out a lot of cash to get access to these drugs. However, we've got a problem. All of the studies that we've run so far have been animal studies. We've run them in rats, in mice, never in a human being. And so, although our results are promising, we don't know for sure that they're going to work in human beings. And moreover, if we're going to get approval from regulators in the United States, say the FDA, Federal Drug Administration, then we are going to have to run some human studies. And so this is what they want from you. They want you to give them $100,000 in cash. If the drug is approved, then you will get $1 million from them. And if the drug is not approved, then you get nothing. So they're expecting you to take the full risk of this investment yourself. Now, if you were offered this proposal, imagine some of the questions that you might want to ask before investing. All right, a few things that you might want to know are, first of all, who are the scientists that are involved? Now, you know that they're from Harvard University. That's a good sign. But this might not be their area of expertise. They might not be particularly experienced. You would probably want to know something about those scientists to make sure that this isn't just a wild goose chase, that you have a decent chance of a return on your investment. Secondly, you might be interested to know what were the exact results of the animal tests. Okay, were there any side effects that might prevent approval for their use in humans? Fair enough, they might be able to regrow hair in lab rats, but if they also cause tumors or some kind of health problems, then the drugs are unlikely to get FDA approval. And third, you might be interested in knowing who else is investing. Who else have they gone to for money, and have those investors put up some money for this? If there are other well-known investors that are putting their money into the project, that's probably a good sign for you. It means that other people have looked into this, they're taking it seriously, and they believe that it's a good risk. On the other hand, if no one else has been interested in investing their money, then that might be a bad signal to you that perhaps they're coming to you because you're sort of a last resort, or maybe they think that you're less sophisticated than the other investors in the market. Finally, you might be interested to know, how long does FDA approval take? I mean, is this going to be a payoff that you would receive 1 year from now? If that's the case, then that's a pretty good return on your investment. On the other hand, if you're going to have to wait 10 years or 15 years or 20 years, then it's not going to be so attractive to you. Now, the first three of those questions deal with the probability that you're going to earn your money back. The fourth question deals more with your time preference over the money. We're going to deal with the first three questions, or what they tell us about economics first, and that's this notion of probability, the idea of how likely is it that I'm going to receive a payoff. This question of probabilities is an important one because for most business strategies, future earnings are uncertain. If you introduce a new product or you try a new marketing strategy, it might turn out very well. It might turn out very poorly. We can think of them as sort of lotteries. To an economist, a lottery is any situation where you have a set of possible states of the world that will give you different payoffs, and there is some probability associated with each of those different possible states of the world. Let me give you an example of how strategies can lead to uncertain outcomes. The two pictures on this slide show you possibly the best and the worst branding decisions that Coca-Cola has ever made. So on the left, we have Diet Coke. It was introduced in 1982. It was not the first diet soft drink on the market. It wasn't even the first diet soft drink that Coca-Cola sold. In fact, earlier than 1982, they had been selling a diet soft drink called Tab. You may or may not have heard of it before. It's difficult to find nowadays, but back in the 80s, it was sort of everywhere. But Diet Coke represented the first time that Coca-Cola decided to sell a diet product with its own name on the label. Up until this time, what we now think of as Coca-Cola Classic, that was the only soft drink that was ever sold under the name Coke. So deciding to take that name that Coca-Cola had put a lot of time and effort and money into building up. To take that name and to put it onto a new product was a controversial one, and it was a risky one. But in the end, it paid off big. They introduced it in 1982, and within that year, Diet Coke quickly became the third highest selling soft drink in the world, and it remains the third highest selling soft drink in the world. Number one is regular Coke. Number two is regular Pepsi. Number three is Diet Coke. On the right, we have the infamous New Coke. New Coke was a beverage that Coca-Cola introduced in the mid-1980s, and it is not remembered as fondly as Diet Coke is. So the story here is that in the early 1980s, Pepsi, which of course was Coke's major competitor, it was gaining market share. Pepsi had sponsored a taste test, which was called the Pepsi Challenge, and it was reporting a 2-to-1 preference for Pepsi. So people who were taking this blind taste test were rather overwhelmingly saying that they preferred the taste of Pepsi to the taste of Coke. As a result, sales of Pepsi were starting to increase. Sales of Coke were starting to flag. And so Coca-Cola responded by changing their formula. Essentially, they said, what we need to do is change the way that our soft drink tastes so that it is more similar to Pepsi. They introduced New Coke in 1985 in the summer, and for a couple of weeks everything looked okay. Sales stayed pretty strong. They were getting pretty decent feedback from customers, but it didn't take too long before there was a backlash. And the backlash was pretty major. There were some consumers that got so upset that the original version of Coca-Cola was no longer being sold that they filed lawsuits against the company. Whether or not they had standing is another question. They wrote letters to their congressman. It became such a big deal that late night talk show hosts were telling jokes about New Coke and how bad it tasted. And it only took 2 to 3 months before the original formulation of Coke, what we now call Coke Classic, was reintroduced to shelves. It probably would have gone back on the market earlier, but they had sold out all of their old formula and didn't have any of the syrup to start producing it again for those 2 to 3 months. So, of course, New Coke has gone down in history as one of the major debacles of the Coca-Cola Corporation. Let's go back to firms and lotteries. Now, remember, a lottery is a situation where there's a set of possible payoffs, and each possible payoff has its own probability of occurring. So imagine a lottery where I flip a fair coin. It has a 50% chance of coming up heads. It has a 50% chance of coming up tails. If I flip heads, I will pay you $900. If I flip tails, I will pay you nothing. So the question is, what is the financial value of this lottery? We answer that question by answering a slightly different question. That's the following. If you were to play this lottery over and over again, let's say you had me flip the coin 1,000 times, how much would you expect to earn on the average coin toss? Well, about half the time, I'm going to flip heads, and you're going to earn $900. About half the time, I'm going to flip tails, and you're going to earn nothing. So if you added up all your payoffs across those 1,000 coin flips, and you divided that total by 1,000, on average, you would expect to earn $450. We call this average payoff the expected value of the lottery. It's the amount that you would earn on average per play of the lottery if you got to play it over and over again. Now you can calculate the expected value by multiplying each payoff in the lottery by its probability of occurring. And then you sum up all of those products. You can see how this works in the coin toss lottery at the top of this slide. You can see that there is a 50% chance of earning $900, so we multiply 0.5 times 900. And there's a 50% chance of earning $0, so we multiply 0.5 times 0. Add those two products together and we get $450. Now, in general, if you have a lottery with, say, n different payoffs, and of course then there's n different probabilities of each of those payoffs, then the way that you would calculate the expected value is given at the bottom of the slide. What you do is you take the sum for I equals 1 to n of the probability, pi, times the payoff, xi. We call that entire sum the expected value, which we denote by the functional form e of x.